All right, hello and welcome to the programming lecture for this week. I have some fun stuff for you. So we're going to learn how to store stuff in variables and then also how to ask questions and do different things based on the answer. So that's two very important concepts in programming. So let us get started with this thing called a variable. So I'm sure you use this in algebra, right? But in computer science it's slightly different. A variable, I want you to think of it as a box. Okay, so a var is a box. This will come in handy. So I can make a variable called x to use in my program, and it can hold whatever I want to put inside of it. Okay, so maybe I want it to hold 1,234, but maybe in a second I want it to hold 42. It's a box, and I can put whatever I want in it, and I can swap elements out as well. Okay. And then I can do computations based on this box because I don't have to say 1,234. That's extra typing. I don't need to ever say that again because now I can say things like x plus 1. Okay, if I ever want 1,235, instead of typing that out, I can just use x, because that's what it is, to make the next thing. Okay, that turns it into it. Okay, so in Scratch, you can actually ask the user of your Scratch program to enter something, and the answer that the user gives back is stored in a special variable called answer, but I'm going to call it input for this slide just so that we get used to different names for variables. Okay, maybe the user types something and we get it as 42 in the input variable. Okay, and then you can use that in other places, like to print out the answer that the user gave us back. Okay, you can say you can now say input plus 1, and that'll give you 43. Okay, to use in a larger context somewhere. So what I'd like to do in my first example program for today is make a slightly more complicated hello world program in a sense, but it's not hello world anymore. It's hello, hey, I'm going to get your information. Tell me your name. I'm going to say hello you. Okay, and then an exclamation point. So that's really exciting. So let's set this up in Scratch. Okay, are you ready? So go to Scratch and click Start Creating. I had to look this up because I didn't know what it meant. All right, close, make large, please. Okay, so here's our Scratch, and we're going to need something to start our program, of course. Let's get that green flag up in there. And so what we'd like to do is have the Scratch Cat ask us, hey, what's your name? And then it'll say hello. Okay, so let's have like a surprise. Oh no, I don't want a sprite. I want a surprise backdrop. All right, this is our theme. All right, so I want to have the Scratch say something and then ask me something back. Okay, so you can say print, but there's an ask block. Okay, that's where I'm going with this. So we can ask, what's your name? And wait, it's you can change this prompt to whatever you want. But I'm good with this one. You can say, like, what's your favorite color? But I'm happy with name. And what's going to happen is when I run this program, it's going to ask what my name is. I can say Lawton, hit enter, or also this click the check mark, and now nothing happens. But secretly, in the answer variable, which is right here, this is what a variable looks like. It's not a block. It's something that can be put inside a block. The answer variable now holds, and I'll prove it to you in just a second, it now holds Lawton. Okay? So it's a box, and I put inside of it by answering the Scratch Cat, Lawton. Okay? So, if you have a different name, I don't know, oops, you can type your name and answer will hold that. So if I click answer, it shows me what's inside. Right now it holds Lawton. I can rerun this program and say, all right, what's your name? I don't know. My mom's name is Linda. So now it holds Linda. You see that? So with each run of the program, the variable that is stored inside of answer changes. Okay? So some dots. And the kind of things that are in these boxes, they're words, okay? They're text, and in computer science we call that string, okay? So text data in CSCI is called a string, okay? So think of it like a friendship bracelet or something where you have a bunch of beads with letters on them. It's just a bunch of characters. And this is quite different, and we'll get into this more when we study Python probably. There's a huge difference between the string 42 and the number 42, okay? So a string is not a number, but it's possible to have a bunch of numeric characters, and there's a difference, okay? But for now, I'll leave you with this. A string is not a number. Okay, so if I put in Lawton, it's quite different than me putting in 42, okay? Because I can add to 42. I can't, like, add +1 to Lawton. They're different types of things, okay? So the key idea is variables have types, and those types determine what you can do to them, okay? And let me just move this on over here, and hopefully it'll be happy. Good enough for now. It kind of bothers me that it's going over that number, so there we go. That's where I want to be. And yeah, so let's keep trucking. So what I'd like to do is use this answer variable to have the scratch cat say, hello, you. Okay, so what we're going to do is use a join block, and I'll show you how that works in a second. But let's get there. Okay, so we can say something back, right? We can say something for 2 seconds. We can say hello for 2 seconds, but we can also say what our answer is for 2 seconds. You see this? I'm going to drag it in here, and now I'm saying a variable. This program is not always the same when I run it, because it depends on what I type now. So I'm going to say Lawton, hit enter. That's going to store Lawton in answer, and now it's going to say back to me, Lawton. Isn't that cool? Same for Linda, okay? Or whatever your name is. So that's perfect. That's exactly what we like, and now our programs are different. And now the answer variable is driving this, okay? That's really cool. If you want to say hello, comma, Lawton, you want to combine 2 strings, okay? So you combine 2 strings with an operator, okay? You can have operators with numbers, and we'll get there. But you can combine strings with these ones. You can join 2 strings together. You can get individual letters out of strings. You can get the length of a string. You can see if a string contains something. And so this is all useful. So join apple banana, the result of that is apple banana. Ooh, that's useful. Apple contains 8. That's true, it does. Length of apple, it's 5. Okay, so I don't really care about, oops, you can put them together if you want. Delete. So I'm going to use this join to say hello, comma, answer. Isn't that nice? Because now if answer is Linda, it'll join hello, comma, and Linda together, but it kind of misses that space. So let's add the space. Hello, comma, space. So now it's hello, Linda. But where's the exclamation point? We need that. And so the answer is, you can combine joins. Okay? So, let's pretend I typed in my name. You can combine these joins, and it will say back to you, if you do this, hello, comma, this is a space here, comma, space, Lawton, because that's what answer is. And then after that one, after it's made that string, it then joins the exclamation point to the end of that. You see that? So the whole thing is that, and we get there by first creating the string just hello, comma, Lawton, without the exclamation point. So that's how join works. And let me show it to you. So we're almost home free. So I need one more join. I'll join hello, comma, with the exclamation point. And if I click this, it says hello, comma, Linda. And if I put it here, it says it. Boop. What's your name? Lawton. Hello, comma, Lawton, because it joins hello. Answer is now storing Lawton, and then the exclamation point. And join is an interesting creature because it's a type of operation, like in math, that is associative. You can do things in either order. So if I can maybe copy this, duplicate, yeah, beautiful. So I can do it in this way. I can say not join of a inner join, if that makes any sense at all. I can say hello, comma, and then I can join answer and exclamation point. Let's see if I remembered my space. I did. You see how these are two different things, but they can give you the same answer. It's just the order of which you do these inner operations, these inner joins. So here's a join over here. We join the hello and Lawton first, or over here we join answer and exclamation point first, and then we tack hello on to the front. So I hope you notice the difference here. Please yell at me if you don't. But this is a fun little example, I think. So that is the Scratch Cat talking to us finally. And now we have a program that works differently depending on what the user is giving to us. And so now the next thing that I want to talk about is using numbers as inputs. So getting a number back from the user and then doing number stuff with that. So we're going to get the absolute value of the user's input. So for this program, maybe we'll do something like ask the user for a number. And that'll then be part of the answer variable, right? Ask the user for a number. That is an S and it looks bad, I am sorry. And then we will output the absolute value of the number. I know, very exciting. So, for example, if the user enters like 42, it's our job to give back 42. Or if the user inputs negative 42, it's our job to give back 42 again. Okay, so that's the name of the game. We're just going to essentially do the same thing as the saying hello, but we're going to make it work with numbers instead now. Okay, let's make this large. So this program is not going to start when the green flag is clicked because I'm having many small programs in this larger program. Okay, so we're going to make a smaller program that starts now when the sprite is clicked. Okay, so we just go to the events, we say when this sprite is clicked, now a different program will happen, different to the green flag is clicked program. Okay, that's all. So let's get that set up. We first need to ask again. I wonder if I could duplicate this. Hey, what number do you want to enter? Something like that. Let me get rid of this one because we don't want that. Sure. So enter a number maybe. And wait. And so this time, when I click the sprite, oops, I have to stop the entire program. This time, I run this program by clicking the sprite first of all. It says enter a number. I can say 42. And now, same with the answer. Answer is still holding whatever I got, but now it's holding a number. Okay, that's all. So then I can say, dun dun dun. I can say the absolute value of blank is blank. Okay, something like that. And we'll use a ton of joins for this. So say, let's see here. We'll just take as many as we need. So I need to say the absolute value of answer. And then I need to say is. And I am going to forget the spaces right now. And then I'll put the absolute value of the answer. And it's up here somewhere. One of these. There it is. So we have abs. Abs stands for absolute value. And you have a bunch of other ones as well that you can choose here. I'm going to keep it as the default. I want the absolute value of the answer. Boop. So this whole darn thing creates this string. The absolute value of 42 is 42. So I forgot some spaces. It's very easy to see where. So after the of, so everywhere. Answer, oops, oh no. Can I undo that? Yes, thank goodness. Let me zoom out a little bit. The absolute value of the answer after the space. Space is, because we want spaces around the previous word and the next word, is 42. Okay, so this will work now. No matter what the value we give it is. So again, click the sprite to start this program. You can see it highlight. So I'm going to give negative 42 now. And it says the absolute value of negative 42 is positive 42. It's perfect. It's just taking answer, which holds a number, and always doing the absolute value of it. Okay, so that's how you can do numerical operations. I encourage you to play around with these operators. Okay, so that's all well and good. And we have two cool programs right now. They do different things when we run them depending on what the user types in. That's lovely. But we do have a bit of a problem, and this will only come up when I show you what we can do if we get around this problem. So right now we have like our little event block that starts the program. It's got like, I don't know, when green flag clicked. And then we have little cutouts there for our little blocks that fit together oh so nicely. Whee! And then we have programs. Okay, this is like an entire program. It starts when you click the green flag. Okay, essentially, this is like maybe 3 blocks, A, B, and C. It runs them in a straight line. Okay, we got A, it runs A to completion. Then once it's done, it runs B. And then once that is done, it runs C. So, wouldn't it be nice if we could do something other than this? Excuse the sound in the background, my cat is playing with a toy. So, I'm going to put it in rainbow just to show us what I'd like to have. So, right now we don't like straight lines. So, let me show you the options that we have here. You can have what's known as branches, if I could spell branches. Oh, my cat is going hard at that toy. And then we have loops. Okay, so a branch is if you were to do something like this. To do, based on the result of A, do B or C, and then come back later and do D. So that's very different from this. And then a loop is, well, I draw a loop kind of thing. It's do A, then B, then come back and do A again. On and on and on until you want to stop, maybe. So those are the two things that we would like to have, and we can't do yet. We need extra blocks for them. Okay, so before we get there, I would like to talk about custom variables. Okay, because right now we've been using the answer variable, and we can make our own. Okay, so we can make our own variables. It's quite nice. So let's make our own variable and call it x, and then we can have whatever we want stored in x. Okay. X can also hold things just like answer can hold things. And this will come in handy later. All right, so let me recreate this program. First, we're going to make an x variable. Okay, we can make as many variables as we want. They're down here in the variables block. Okay, so you get one to start with. It's called my variable, but you can right-click and rename it. So I'm going to rename this my variable to x, and then you can make another variable if you want. Just be like, call it y. And you can choose if you want the variable to exist for the current sprite only or for every sprite in the program. It's up to you, because we only have one right now anyway. So x is going to come in handy for us. Right now, it holds 0. That's like the default value for a variable. But we can give it anything by using the set block. So we can say set x, or whatever variable we want, to, I don't know, 42. Okay, or I guess in the example it was 44. So x is now 0. If I run this block, click it, x is now 44. This is interesting because then I can be like, okay, show variable x. It shows it up here in the screen if you can see my mouse. X is 44. Then I can change the variable, change x by 1, click that. Now you can see x is 45, show it again. Yeah, so that is the name of the game. Let me recreate that program for you now though. So this program is going to start when the space key is pressed, if I remember right. Yep, when the space key is pressed. So here's another event for us. I'll put it up here, I guess. So now when the space key is pressed, a different program will start, this one. So first we'll set x to 44, then we'll change x by 1, which makes it 45. You can also go down in the opposite direction and be like, change x by -1. Ooh, now it's 43 if I click it twice. So get it back to 1. There it goes. Okay. Actually, we should show it in between. Show x, change it by 1, and then let's show x again. And I want you to take a second, pause the video, and think about what might happen. You probably already read the slide, but I do want you to think about it. So when I run this program, I actually don't need x here anymore. I'll just keep it here for fun. When I run this program, well, it's going to do these 4 things in order. It's going to set x to 44, it's going to show x, so it should show 44, then it's going to change x to 45, and then show 45, right? So I'm going to press space now. Drum roll, please. Boop. Okay. I'm going to press it one more time to rerun the program. I'm going to press it a million times. What's going on? This is a very interesting concept in computer science because a lot of the time it's me making fun of the computer. Right now I am going to praise the computer. Our computers are really fast. Okay, so if you want to see something in the middle of a computation, you have to wait a little bit. You have to make your program stop or output something in a different way. Okay, you could have it say stuff for 2 seconds again if you wanted to, like we did in our program way up here. You could say stuff for 2 seconds, that stops the program and says stuff for 2 seconds, then moves on. But the show variable just immediately happens. The issue is, if I go back to the slides, oops. The issue is this line right here. It happens, and then we immediately execute this block. Change x by 1, and then re-show x. These 3 things happen so quickly you cannot see when it says 44. It should show it, but it does not. Our computer refreshes the variable's value so fast that the screen cannot show the changed value, because our screen refreshes slower than our computer thinks. Okay, so if you want to see something, you got to make the computer wait. So let's do that. Let's make it wait. There is a wait block somewhere here, and it's in control. Okay, so here, if we want to show this 44 for a second, exactly 1 second, we have to wait. I have to just tell it to wait, please. So now I'm going to press space, and you can see how it says 44 for 1 second and then shows 45. So it really did show 44 before. The computer was just so fast we couldn't see it. Okay, so that is custom variables. And now before I get to conditionals, which are these branches, which are really cool, I'm going to show you loops because they're very, they're fun. Okay, you can make animations happen with loops. So one more program. When the up arrow is pressed this time, we are going to make our scratch cat do a loop-de-loop. Okay, we're going to make our scratch cat spin very fast or slow, depending on how fast we ask it to spin. So here's what we're going to do. Okay, we're going to introduce this thing called a repeat block. All right, so when you say repeat, you can have optionally a certain number of times. And inside of this repeat block goes as many blocks as you want, and they will get repeated that many times, okay? So if this holds 10, so the inner part gets run 10 times. Okay, this is really fun because we can watch the scratch cat move. So we are going to ask after the up arrow is pressed, so not space anymore, but the up arrow. We're going to have the scratch cat ask us, how fast should I spin? Oops, it's down here. How fast should I spin? And then it waits for our answer. And then we have answer. We'll hold the number that we want to use to control how fast we spin. And then we're going to repeat 10 times. Okay, this repeat block can take blocks inside of it, which is interesting. we're going to spin our scratch cat, which is up here in motion. Turn, I guess, clockwise is fine. We're going to turn answer degrees, not 15 degrees, not any set number, but answer degrees. We're going to do that 10 times, you see. Okay, so let me add a comment just to drive this home. Turn clockwise by answer degrees 10 times. This will be really fun. All right, so let's do the normal one. I guess let's do 15 degrees. Why not? I think that was the original default. So I'm going to press the up arrow on my keyboard. And how fast should I spin? How about 15? Hit enter. Whee! So there he goes. 15 degrees is causes him to move that quickly. Oops, I just clicked the scratch cat, which started the old program. All right, I'm going to press the up arrow again, and let's do 25. That's a bit faster, isn't it? Up arrow again, 35. Ooh, 50? Yeah, so I think you get the idea. And this repeat block just repeats the inner program as big as you want it to be. It can be multiple blocks long. It'll take more, no problem. It'll let them go right here. That's fine. We only need the one though. Okay, so that is loops. It'll be very helpful for animations, and I really encourage you to play around with that. Now I want to get into the next main topic, conditionals, conditions and questions. So again, we want our programs to branch. We want to do one thing or another based on the input that we get. So like if answer is equal to 42, do one thing. Otherwise, do another thing. And then maybe once those things are done, we'll come back and do another straight line program. Something like that. That's what we would like. And in order to get there, we need to talk about true and false. If you remember that I showed you a little bit about it, one of those operators on strings gave back a true or false value. Like, does apple contain an A? Yes, that's true. Does it contain a B? No, that's false. Ooh, okay. True and false are what we can use to control how our programs execute. And that's the key idea. Okay? A true/false variable is called a Boolean variable. A Boolean value is just a value that takes on either true or false, named after our friend George Boole. And so we can ask whatever kinds of questions that we want. One nice one is, hey, is the answer variable less than 0? Because we can do something if that question is true. If it's false, we can do whatever we want. And we can control the way the program runs. And so what I'd like to do is to go back to the absolute value example and do it better. I want to make our own absolute value without having to use the abs block. Okay? So we're going to get there by using conditions. Okay? So this is going to be how our program works. First, we'll get the input again. And then we're going to test. Check if the input was negative. That's a 0. If it was, if that was true, we're going to multiply it by -1. Because that will turn the input positive. Yes, this is how we make absolute value, really. And then we'll display the number. And if it was false, this original test, if input less than 0 was false, that means it was really greater than or equal to 0. Okay, I hope you see that. And just reverse the number line. And in that case, it's already positive. We're done. It is its own absolute value. We can just display the number. Okay, so that's really fun. And so here are two options. We have option 1, if answer stores -42, then we're going to set it, we're going to multiply it by -1 and get back 42 in that box. Otherwise, if answer was originally 42, we're not going to touch it and just display it back. Okay, and oops, I added an accidental extra negative. Now we're supposed to get rid of the negative by multiplying by -1 times -1. Okay, so that is the name of the game, and the way we get there, the way we can do this stuff, is by using an if-then-else block. Okay, so let me try and explain this. It's still down here by control. Next to repeat, there's forever. I encourage you to see what that does. We have if-then, and then if-then-else. Okay, so let's talk about if-then-else. So here, it's a different kind of spot. It's a different shape. This is a shape for a condition, okay? The condition goes here. It must return true or false. Must become somehow, let's say. If I could write, must become true or false. One or the two. So this must become true or false, otherwise it doesn't work. And that controls which of these we execute. Okay? If the condition, I'll call it cond, if it's true, we'll do all the stuff here. Okay? So executed if cond is true. And this one, I think you understand the name of the game. If cond is true, then we do one, else we do another. Okay? And so this 2 gets executed if cond is false. And of course, you can put more stuff after both of these tests. Either 1 or 2 happens, and then you can do the rest down here if you want. Okay? So, and remember, you can put as many blocks into these as you would like. We can use this now to make our example. And then we'll, that's all. Then we'll get out of here. So, are you ready? So here we go. Gosh, how do I want to do this? What are the other events that we have at our disposal? Let's see. Wind loudness is an interesting one. It uses your microphone to see if you clap or something. It's very fun to think about. But we'll just do more keys. Let's do, I don't know. How about G for go when the G key is pressed? So what's going to happen here, this is the program that we want to calculate the absolute value of a number. Okay? So what we're going to do is we are going to again ask, hey, what's the number? I guess I could copy all this stuff up here. Enter a number and wait. Okay? Again, maybe I'll duplicate this. If I could bring it down. Oh, no. Come on. Oh. Let me just undo. There we go. I'm going to slowly bring it down here then, so that I don't mess up anything else. Oh. Come on. There we go. Okay. So this part we're going to get rid of. We're going to change that. Dun dun dun. If I can delete it. You know, it might actually be easier to just change a variable itself, but that's all right. How about this? So let's ask, enter a number, and wait, and then we get the number in our answer again. And after that, how about we use one of our nice variables? Let us set our x variable, because why not, to answer. And we'll work with x instead of answer so that we have a chance to do something other than manipulating answer itself. Then, something interesting is about to happen. So we need to now branch. We're going to include our if-then-else, which is going to, yeah, I think I'd rather just get rid of this one. We're going to test now whether x is positive or negative. Okay, let me add a comment here to describe what I'd like to do. So first, we'll test if x is negative. If it's negative, we'll negate it in the true branch. We call this this bit the true branch, this part right here. So true branch, we say. And likewise, this one is the false branch. So if we hit the true branch, we're going to negate x. If it's already positive, if it's non-negative, I guess 0 is fine too. Do nothing. Or don't change x. And then we'll just output the value. Okay, so this is what we want to do. And so we need to now test if x was positive or negative. I'd like to create a condition that reflects this one right here. So was my input less than 0? Was x less than 0? Okay, so I'm going to take my x, here it is, and I'm going to need to make a test for it. Was it less than a certain value? Was x less than, not 50, but 0? Okay, that's the idea. So let's enter a number. I don't know, negative 42. Now if I click this, because x is negative 42, because we used it to set, it's true. If I press G again, oh shoot, I might have a problem with one of my, let me do down arrow instead. I think I have a problem with one of my Firefox extensions. Yeah, that works. Let's say positive 42. Now x holds positive 42, and so x less than 0 is a false statement. It's not true. 42 is bigger than 0. Okay, so there we go. Let's put this in here, and this will control whether we do the true branch or the false branch. So the first thing that we want to do in the true branch is to negate x. We want to change it to be the negated version of itself. So if we have x being negative 42, we'd like to change that to make it so that x is positive 42. So we'll multiply by negative 1. We want to like set x to be itself times negative 1, if that makes sense. Too many little x characters. Let's use the dot for multiplication. Okay, so we want to set x to be x times negative 1. This is actually possible. It's a weird concept. It's different from like math variables because you can't like reset a variable, but we can actually do just that. We can set x to be, well, whatever it was times negative 1. If we use this, whatever it was times negative 1. So right now, so it'll give us negative 42 because x is currently positive, but if we get to this branch, we know it's negative. So this will make a positive x back for us. And otherwise, we don't want to do anything, we just want to display the value, okay? So let's just, in each case, print out the value of x. Let me have, let's have 2 of those. Okay, so I hope you see where I'm going with this. I hope it's slowly starting to make sense, get those neurons all maneuvering in your brain. So let's walk through how this program is going to work. First, it'll ask the user for a number and store that number in the answer variable. So originally, we're kind of like swapping between those two places. Originally, say if answer was set to negative 42, the very first thing we do is plop answer into x. Okay? That's what happens here. Set x to be whatever answer is. And then we're going to control the program based on the value of x itself. If x is less than 0, if it's negative, in that case, we're going to do these 2 blocks. We're going to set x to be its negated version of itself, so it will become positive. Based on this condition, we know that's going to be true. And then we're going to output the value of x for 2 seconds. Okay? Otherwise, if it's not true that x is less than 0, that means it's positive or 0, we don't have to do a thing. We can just say what x is. That's already the absolute value. Okay? So this entire program computes the absolute value of the input variable. Okay, the computer computes absolute value of the answer variable originally. Okay, are you ready? I'm going to press the down arrow, and here we go. So enter a number. Let's do -42 because that's the harder case. And hey, we get 42 back. So again, setting x to be -42. -42 is less than 0. We're going to set x to be -42 times -1, which is positive 42. And then we're going to say that new value of x. See that? So we hit the true branch. Alternatively, I can say 42. And we're going to hit the false branch. And it's not going to change. It won't hit these blocks because we're going straight here, straight to the else branch, the false branch, and outputting the value of x just immediately. Okay? So that is, in a nutshell, conditionals. And you're going to get very acquainted with this kind of reasoning. Okay? So all you need to do to control an if-else statement is to use these conditionals that look like this, that return true or false. It's hard to miss them. Okay? So now I think we're ready. I think we're ready to get started on our next homework assignment. Okay? Our next programming assignment is going to involve an if-then-else block. Okay? So you do download this program that I share with you and get a feel for it, because you will be using your very own. So what I'd like you to do for your next programming assignment, this one's going to be due on January 28th. For this assignment, what I'd like you to do is teleport the Scratch Cat, or whatever sprite you choose. You can pick a different one. It's totally fine. Oops. You can change your sprite to be whatever you want, but it needs to teleport. Get as creative as you'd like, but this is what needs to happen when you run your program. When the sprite is clicked, your program needs to do the following. Okay? It needs to hide the sprite and then make it magically appear in a random place on the screen. Okay? You can get around using the hide block, but you can use it if you'd like, hide and show. So clicking on your sprite, whatever one it was, it should make it appear at a random place on the screen. And then you should compare your sprite's location to the middle of the screen. Okay? You're going to compare its y value. Okay? So if this is your sprite, it's below the middle line. Okay? Or if it's up here, it's above the middle. Okay? Something like that. So what I'd like you to do, based on your new random location of your sprite, is output, hey, I'm above the middle, if your sprite teleported above the y equals 0 line. So this is y equals 0. Remember that all sprites have an x and a y coordinate. So if the sprite ended up here, we have a positive y coordinate. If you ended up down here, we have a negative y coordinate. Okay? So use that, and use this variable right here. Okay? You have a y position variable. These are the things that you'll need to use for this. Y position tells you the position of the current sprite. Okay? It's currently -84. It's a variable. It changes. It's currently 89. So you're going to use this variable to determine your current y position in your program. Okay? So that's almost there. So take a look at where your sprite is compared to the y equals 0 line, and then say, I'm above the middle if you're above it, or I'm below the middle if you're below it. Okay? One of the two. And you can choose whatever text you want to say, but it should be different in each case. You can optionally play a fun sound after it teleports with one of these sound effects. You can play a meow sound. You can make your own sounds. I think there's a pop sound somewhere. That's fun. Yeah, I think that should be all right. You must use the following blocks. So you need to use if-else. So let me just drag some blocks down here that you're going to probably want to use. You're going to need to use when the sprite clicked, of course. You're going to need to use y position. You're going to need to use if, then, else. You're going to need to use something involving randomness. I'll let you pick, like go to random position or glide to random position, something with random in it. One of the two. That'll be useful. One of these. What else? Got an if-else block. Yeah, you'll need to say stuff. I'll let you figure all that out. But I think that is all I want to say. Yeah, so your program, again, it's going to, you click the sprite, it randomly sends the sprite somewhere. You're going to look at the y value, the y position variable of your sprite. If it's positive, you're going to say, I'm above the y equals 0 line. Otherwise, you'll say, I'm below the y equals 0 line. And that is the minimum requirement for this. Okay, I hope that makes sense. I hope this is well enough explained. Please yell at me if it's not. And in order to turn this in, I don't want you to send it me in your Scratch file or anything. I would like you to record yourself demonstrating your program. Okay? I'd like you to upload a video of your program running. Okay? You can record it with your phone. Zoom has a nice screen recording feature. If you have not seen that before, I can teach you how to use it very quickly. Zoom. Let me show you that. Dun, dun, dun. So eventually I'm going to require you to record your programs. It's not required this time. You can send just a screenshot, but this is what I would like you to do. Okay? So you can share your screen and then click record down here, and that will record a video of yourself. Okay? That is how you could do it, one way. I also use this program called OBS. It's very useful. OBS up here. Let's see. Yeah, if you can't upload a video this time, then you can upload a screenshot. Just make sure your code is visible to me. And then I'm going to require, eventually, you to record your screen to show me your program's running. So come to my office hours if you can't figure out how to do it. Okay, so I think that's everything. This is going to be due on January 28th. And yeah, have fun with it. And I'll give you all these programs that I wrote today. Please study them. And that's all I got for you. I'll see you next week.